Hi, we are the Group 7, and we are here to discuss to you the spontaneous change, entropy, and free energy. This presentation has three objectives. First is to predict the spontaneity of a process based on entropy. Second is to explain the second law of thermodynamics and explain its significance. And last is to use Gibbs free energy to determine the direction of a reaction. Let's begin with the first objective.
Objective 1. Predict the spontaneity of a process based on entropy. To begin with, there are two types of chemical reactions that occur in the environment, which are classified as spontaneous and non-spontaneous. Spontaneous reaction occurs when reactants are mixed under certain conditions and the reaction occurred. Non-spontaneous reactions, on the other hand, occurs when the reactants are mixed under certain conditions and the reaction did not occur. The term spontaneous refers to something that happens on its own. Kusa itong nangyayari kahit di ka na makialam sa process o kahit walang idagdag o gawin na work. For example, what will happen to water given the temperature is at 100 degrees Celsius and at 1 atmospheric pressure? So, the water will spontaneously boil. Di mo na kailangan haluin ang tubig, kusa na itong kukulo base sa given na temperature at pressure. Ngayon naman, how can we predict if a reaction will spontaneously happen? For us to be able to predict whether a spontaneous process will occur, specifically a spontaneous reaction, we have to look at these factors: enthalpy, entropy, and temperature. The symbol for enthalpy is read as delta H, change in enthalpy. So, enthalpy is a thermodynamic quality used to describe heat changes taking place at a constant pressure. Most exothermic reactions are spontaneous. When we say exothermic reactions, there is a release of heat. Halimbawa nito ay burning of food and digestion of food. Some endothermic reactions naman are spontaneous. While endothermic reaction means a reaction where heat energy is absorbed. Halimbawa nito ay cooking of rice, melting of ice, and boiling water. Since it is not 100% because it is only most and some, then therefore, energy changes in the system is not enough to predict the spontaneity of a reaction. It needs the other factors to predict whether a reaction will spontaneously occur. The next factor is entropy. It is a measure of how dispersed the energy of a system is among the different ways the system can contain energy. These different ways are the microstates. Microstates are the states of particles where energy of the system can be distributed. In second law of thermodynamics, it is said that the tendency of the universe is to proceed into higher entropy or more disorderly system. So the higher the entropy, the more microstates. This means the universe favored to a much disordered system. More chaotic system means more microstates, and if there are more microstates, there will also be higher entropy. The higher the entropy, then the reactions will spontaneously occur. More microstates means higher entropy. The higher entropy means the higher the spontaneous reactions. So kung titingnan natin dito, gases have more dispersed energy because it has more microstates. Mas dispersed ang energy kapag mas marami ang microstates.
Temperature. Temperature is the average translational kinetic energy of a system. Translational kinetic energy is the energy due to motion from one location to another. For example, which has more average translational kinetic energy, ice or water? Since translational kinetic energy is directly related to temperature, the higher the temperature, the higher the translational kinetic energy. It means the particles moves faster from one position to another. So, water has more translational kinetic energy because it has higher temperature than ice. Water's particles move faster from one position to another. At higher temperatures, more energy gets distributed or dispersed, and more microstates are available. The mathematical equation for the second law of thermodynamics is the change of entropy of the universe is equals to the change of entropy in the system plus the change of entropy in the surroundings. If the resulting change in entropy of the universe is greater than zero, then the process is spontaneous. If the resulting change in entropy of the universe is less than zero, then the process is non-spontaneous. And if the resulting change is equals to zero, then the process is at equilibrium. To fully understand the change of entropy in the universe, let us first understand the change in the entropy of the system and the change in the entropy of the surroundings, beginning with the change of entropy of the systems. The change in the entropy of the system is equal to the change of the standard entropy of the reaction. To get the standard entropy of the reaction, subtract the standard entropy of the product to the standard entropy of the reactant. It is possible that the reactants and the products is more than 2. So to modify the equation, the standard entropy of the reaction is equals to the summation of the moles times the standard entropy of the product minus the summation of the moles times the standard entropy of the reactant.
So, how to predict the spontaneity of a process? Given the chemical formula, the change of standard entropy of the reaction is equal to summation of the moles of the product times the standard entropy of the product minus summation of the mole of the reactants times the standard entropy of the reactants. For example, given here is calcium carbonate and yung which is the reactant, and yung product na nabuo is calcium oxide and calcium dioxide. Given their value, which is there is a table in standard entropy na given yung value ng bawat compound. Given here is calcium carbonate has 92.9 joules per Kelvin, calcium oxide has 39.8 joules per Kelvin, and calcium dioxide has 213.6 joules per Kelvin. Don't forget that yung unit for entropy is joules per Kelvin. And to sum up, yung given yung formula of change of entropy, standard entropy of reaction, and substitute the product and the reactant. Product, which is the calcium oxide and calcium dioxide, and minus the reactant. Add yung product, which is 253.4 joules per Kelvin, minus the reactant, which is 92.9 joules per Kelvin. The answer is 160.5 joules per Kelvin. So, based on the second law of thermodynamics, kapag positive po yung answer, it is spontaneous, and kapag negative, it is non-spontaneous. Let's get to another example. We have nitrogen, which is gas, and hydrogen gas, which these are the reactants, and yung product na nabuo nila is ammonia, which is gas. Given their standard entropy, nitrogen has 109.5 joules per Kelvin, hydrogen has 131 joules per Kelvin, and ammonia has 192.5 joules per Kelvin. Given the formula of change of standard entropy of the reaction, substitute the reactants and the product. Remember po na yung product is always in the left and yung reactant is always in the right. Given dito is yung product, since may 2 yung given, i-multiply yung value ng product into 2. And minus the reactant, which is yung yung nitrogen has of 199.5 and yung hydrogen naman 131 joules per Kelvin. Then multiply din by 2 kasi may 2 din dun sa value. And the change of entropy of the reaction is equals to 385 joules per Kelvin minus 383 joules per Kelvin plus 131 joules per Kelvin. Remember that yung reaction always the change of the entropy of the reaction is 385 joules per Kelvin minus 504 din kasi yung sum nito ng reactants joules per Kelvin. The sum up, the answer is 121 joules per Kelvin. Di ba sabi ko, if negative yung answer, it is non-spontaneous. Since negative ito, yung given example here is non-spontaneous. Let's get into another example, which is hydrogen gas and chlorine gas equals to hydrogen chloride, which is gas. Given their standard value of entropy, hydrogen has 131 joules per Kelvin, chlorine has 223 joules per Kelvin, and hydrogen chloride has 187 joules per Kelvin. Using the formula, substitute them, the product times 2 kasi may 2 na value, and yung reactant naman, reactants kasi dalawa, yung hydrogen and the chlorine. So, add mo yung dalawang reactants and multiply the product. The answer is 374 joules per Kelvin minus 254 joules per Kelvin. And yung sum nila is positive 20 joules per Kelvin. Since it is positive, it is spontaneous. So, I have this table that I have na-search ko po sa Google yung value ng mga compounds. Hindi ito kompleto, pero andito po yung ibang value.
Another way to predict the spontaneity of the process by looking at the phase of the reactants and products. Solids have low entropy, while gases have higher entropy. Example of this is the example number 1 explained by Erisha. We can predict that this reaction is spontaneous because it transitions from solid to gas. Mentioned earlier that gases have more dispersed energy, meaning it has higher entropy. So this example is spontaneous. Second is by looking at the number of moles. More moles means more microstates can be created. Example of this is the example number 2 explained again earlier by Erisha. We can predict that this process is non-spontaneous because the reactant has more moles than the product. More particles present in the system means higher possibilities of generating more microstates. So therefore, example number 2 is non-spontaneous because the reaction is from higher entropy to lower entropy. How the entropy of our surroundings affect the entropy of our system. If the system releases heat, the heat of the surroundings will also increase. If the heat of the surroundings increases, then the entropy will also increase. And if the system absorbs heat, the heat of the surrounding will also decrease. If the surrounding decreased its heat, then the entropy will also decrease. With these situations, we can say that the change in the entropy of the surrounding is directly proportional to the release of heat from the system. Another factor affecting the system and the surrounding is the temperature. If the surrounding has high temperatures, then the system also has high energy. Once the system releases heat, there will be a little impact on the change on the standard entropy of the surroundings. And if the system releases heat in the surrounding and the surrounding has low temperature, then there will be high impact on the standard entropy of the surroundings. With these situations, we can say that the change in entropy of the surrounding is indirectly proportional to the temperature. Since both of these equations refer to the relationship of the enthalpy of temperature to the entropy of the surroundings, we can combine them. By combining them, we could come up with this equation. The change of entropy in the surrounding is equal to the negative delta H over the temperature. This is now the equation for the change of entropy in the surroundings. This equation can be used to determine the spontaneity of a process given the temperature.
The second objective is to explain the second law of thermodynamics and its significance. But to further picture out the concept of thermodynamics, I'm going to include the first law and then we'll proceed to the second law. So what is thermodynamics? Thermodynamics is the science of the relationship between heat, work, temperature, and energy. It deals with the transfer of energy from one place to another or from one form to another. A very common example for this is a solid ice that melts because of heat. First form is ice, and it melts into another form which is into water, and the energy which is transferred is heat. Around 1850, Rudolf Clausius and William Thomson Kelvin stated both the first law, that total energy is conserved, and the second law of thermodynamics. The second law was originally formulated in terms of the fact that heat does not spontaneously flow from a colder body to a hotter. What we mean by spontaneous is that it naturally occurs without external forces, or kusang loob na lang na nangyayari. The first law of thermodynamics states that the energy can never be created nor destroyed. In an isolated system, or a closed system, the energy must remain constant. It can neither increase nor decrease without the interference from outside. Let us refer to my example. Meron tayong 2 boxes and sa first box has 4 green dots. Those are molecules. And for each molecule, we will assume that it has 1 energy. So we have a total of 4 energies. Assuming that each box isolates itself from making contact from the outside, meaning to say walang lalabas na molecule and wala ring papasok mula sa outside, except that the boxes can interact with each other. Even if mag-transfer ang molecules, the total number of molecules will remain constant. Kahit pa maging ganito, like this, or lahat ng molecules ay mag-transfer sa kabila, ang total energy pa rin nila is 4. Here we can see the types of systems. We have open system where energy and matter can move from the inside to the surroundings. Example nito ay kapag nagluluto pero open lid. Yung heat ay pwedeng lumabas sa pan. Yung liquids, especially oil, ay pwedeng tumalsik palabas at pwede ring may pumasok sa loob nito. Next one is closed system. A cup of coffee with a lid on it is an example for this. Kahit pa-sealed at walang usok na lumalabas, meron pa ring daanan yung heat energy which is the container para makalabas siya and consequently transfer those heat into the surrounding. The last one is an isolated system. Very self-explanatory. Isolated ang energy inside at walang matter or energy na dumadaan from both ways. Walang pumapasok at wala ring lumalabas. Isolated system is a thermodynamic system enclosed by rigid and immovable walls through which neither mass nor energy can pass. It is difficult to create an isolated system because naturally, energy is always transferring. Let's take for an example yung thermos natin sa bahay. It is built to keep the water hot, but actually, it only drastically slows the transfer of heat. So eventually, kapag pinabayaan mo ang thermos na may tubig for days, ay mag-cool down pa rin ito. Ganun kahirap mag-isolate ng energy. Ibig sabihin, ang thermos is not actually an isolated system, but rather, it is a closed system. The general idea here is that the number of energy is constant, but due to the fact that our surroundings, our universe can constantly transfer energy, it is hard to observe the energy conservation, but hypothetically makes sense and helps science, especially in the field of thermodynamics. Now we proceed to the second law of thermodynamics. The second law of thermodynamics states that the total entropy of a system either increases or remains constant in any spontaneous process. It never decreases. Heat transfer is the movement of heat from a warmer object to a colder one. When two substances at different temperatures are mixed together, heat flows from warmer to cooler body until they reach the same temperature. Here's an example. If you keep the door open between two adjoining rooms of different temperatures, considering that it is an isolated system, the cooler room will become warmer and the warmer room will cool down until they both reach the same final temperature. To further explain this, here's an analogy. The high temperature will flow to the low temperature cube. And according to the second law of thermodynamics, heat will not flow from low temperature to the higher temperature cube. Here we can see a hill. And then we put a ball on top of the hill, where if we remove our hands from the ball, it will roll down the hill. So the ball came from high to low. The same as the system of two cubes, where the high temperature moved to the lower temperature. What made the ball transfer from one place to another? The answer is gravity. Gravity is a natural occurring force. If gravity is a force, then what force is present in the cubes, knowing that heat is energy? The answer to this is temperature difference. These two are natural phenomena that behaves like force. So what is the relationship of the second law of thermodynamics to these? Well, if we put another hill beside, and then we place the ball instead at the top, we place it at the bottom. The ball cannot spontaneously travel from lower to the higher side of the hill. Of course, unless an external force is applied to it. We can conclude that this is non-spontaneous. We can still possibly place the ball to the top, but it will require an external force to produce energy. In conclusion, with temperature difference, in order to put the first cube at the high temperature and the ball to the top of the hill, energy from outside the system must be applied. Let's take it further. Assume that the left cube has a temperature of 70 degrees Celsius and the cold one is at 10 degrees Celsius. If we connect them, the higher temperature will spontaneously transfer heat to equilibrate the system. What do we need to put back the left cube at 70 degrees Celsius? Since it is not possible to revert the process, absorb the transferred heat from the right cube, the only way is to use external energy out from the system, which in this case, I'll make use of fire, to increase the temperature. Notice that it is very easy for nature to transfer heat from high temperature body into lower temperature one, but it requires greater effort or energy to return it back to its original temperature. This is what it means of the universe naturally creating disorder or entropies. Another example is when you have a deck of cards, places in order from aces to kings, and then you drop it. It is easier to drop the deck than pick all the cards up on the floor and rearrange it. It requires more energy to revert it than to make this order. How about the hill and ball situation? For us to place the ball on top, we need to apply external energy or energy outside of the system to do it. The general idea in the second law of thermodynamics is 1. The universe naturally creates disorder or entropy, and 2. If energy is an opportunity to spread out, it will.
The second law of thermodynamics is very important due to the fact that it accompanies us in our daily life. The law describes that the entropy of a system will either increase or remain constant, but it will never decrease. To understand this law, we should look back on what entropy is. Entropy is the amount of disorder within a system. It can be said that the universe tends to move towards disorder, and that's why entropy is one of the most important concepts in the universe. Disorder will always be present no matter where we go or what we do. If you ever wondered why when two objects of different temperature are placed in contact,
Thermal energy always goes from the warmer object to the colder object. Or why if you start with a glass of room temperature water, you never see some of it cool and freeze, while the rest warms and boils. Then understanding the second law of thermodynamics will help. An example of this law applied in our daily life is when coffee cools down when left in an open space. Based on the second law, the cup of coffee can be considered as a system. It can be said that the coffee loses heat in the process, and the surrounding absorbs the heat, but the coffee cannot absorb the heat of the surrounding because it will violate the second law of thermodynamics. It can be said that this scenario is pretty intuitive, but it cannot be the case for chemical reaction.
Objective 3. Use Gibbs free energy to determine the direction of a reaction. A little history on Gibbs. The quantity called free energy is a more advanced and accurate replacement for the outdated term affinity, which was used by chemists in the earlier years of physical chemistry to describe the force that caused chemical reactions. Gibbs energy was developed in the 1870s by Josiah Willard Gibbs. He originally termed this energy as the available energy in a system. This quantity is the energy associated with a chemical reaction that can be used to do work. It is the sum of its enthalpy H and the product of the temperature and the entropy S of the system. So how do we derive the Gibbs energy equation? So using the equation for the change of entropy in the surroundings and second law of thermodynamics, we could come up with the Gibbs free energy equation. The equation for the change of entropy in the surroundings is delta S of the surroundings equals delta H over T, which is temperature. The second law of thermodynamics is delta S of the universe equals delta S of the system plus delta S of the surroundings. So how do we derive the Gibbs free energy equation? First, you start with the second law of thermodynamics and replace delta S of the surroundings with the equation for the change of entropy in the surroundings. So that will be delta S of the universe equals delta S of the systems times delta H over T. We multiply the whole equation by T, and that will become T times delta S of the universe equals T times delta S of the system minus delta H. We multiply again the whole equation by -1. So that will be negative T times delta S of the universe equals negative T times delta S of the system plus delta H. We switch positions of delta H we switch the positions of delta H and T times delta S of the system. So that will be negative T times delta S of the universe equals delta H minus T times delta S of the system. Delta H minus T delta S of the system will now become delta G or Gibbs free energy. So the equation for Gibbs energy will become delta G equals delta H minus T times delta S.
Gibbs free energy is a state function that determines whether a reaction is favorable or not. A state function is a property whose value does not depend on the path taken to reach that specific value. It is the type of energy associated with a chemical reaction that is available to do work. The Gibbs free energy is simply a method of telling whether a chemical process will take place spontaneously or non-spontaneously. Moreover, it calculates the amount of energy available in a system to do work. If the reaction is accompanied by a release of free energy, that is delta G negative, the process is sure to be spontaneous. Now, this is the formula for Gibbs free energy. Gibbs free energy is denoted as G, which combines enthalpy, denoted as H, entropy, denoted as S, into single value. The formula is delta G is equal to delta H minus T delta S. wherein delta G is change in Gibbs free energy, delta H is change in enthalpy, T is temperature in Kelvin, and delta S change in entropy. In Gibbs free energy, to determine whether reaction is spontaneous, the change in Gibbs free energy must be less than 0 to be spontaneous. If the change in Gibbs free energy is greater than 0, then the reaction is non-spontaneous. If the change in Gibbs free energy is equal to 0, then the reaction is at equilibrium.
So ngayon, we proceed to the sample problem. So Gibbs, in short, Gibbs will help you determine whether the process or the reactions is spontaneous or not. Example number 1. Given the following data, calculate the Gibbs for this reaction and state whether it is spontaneous or not. So, ito na yung given, ito na yung entropy, and then temperature. So, ang hanapin natin is yung Gibbs. So, ito na yung given, nakalagay na. And then, ang gagawin lang natin is ang equation ng Gibbs. Diba, na-explain na din nila. So, delta H minus T plus. So, next step is, check mo if tutugma yung units. So, ito, kilojoules, and then ito, joules. So, hindi siya pareho. So, kailangan natin convert ang entropy to kilojoules. So, conversion nito is dito. So, negative 136 joules per Kelvin times isang kilojoules is equals to 1,000 joules. So, ito lang, cancel, then matatira is itong kilojoules and Kelvin. So, para mabilis na gawin, i-move nyo na lang 3 times to 3. So, negative 0.136 magiging kilojoules per Kelvin. So, ito na ang niya. Value ng entropy in kilojoules. Ito na. And then, input na natin ang enthalpy, and then the temperature. So, ito is enthalpy. Ito yung entropy. Guys, wag malito. And then, ito yung temperature. And then, i-plug in na natin. Gibbs is equals to negative 495.2 kilojoules. And then, minus temperature, 298 Kelvin, times negative 0.0136 kilojoules per Kelvin. So, ito siya. Right. Yan. Then, we solve for the Gibbs. I-times mo lang, and then negative, ang kinalabasan niya is 40.5 kilojoules. So, magiging positive to kasi negative to the right, negative, ganyan, dyan muna pa rin, negative 495.2 kg. So, itong dalawa, magiging positive yan, right? So, ito, magiging ganyan, 40.5 kilojoules, ito, 0.25. So, paano nakuha? Dito pala, nakansel yung Kelvin, yung temperature na, unit ng temperature. So, naging kg na lang. So, dito, pwede na natin i-add. So, 495.2 kg plus 40.5 kg. So, ang sagot niya is negative 454 kilojoules. Ito na yung sagot sa tanong. Dito, mapansin is the value is negative. So, whenever the value is negative, it is spontaneous. Spontaneous siya. Because, sabi nila, diba, kanina, if Gibbs is less than 0, it is spontaneous. So, less than 0 siya kasi negative, diba? The process of the reaction is spontaneous. Kasi nga, negative. Pero kung positive yan, it is non-spontaneous. So, yun. Let's proceed to the sample 2. So, sample 2, what will be the Gibbs of the reaction if its entropy is equal to negative 144 kg and its entropy is negative 36.8 joules per Kelvin at 298 K or Kelvin temperature. So ito na yung given ulit. Present na yung given. Lagyan na yung given. First thing you do is you write the given. So yan na yung given. And then, let's proceed to the equation. Equation of Gibbs. So delta H minus T and entropy. Next thing you do is to check whether ang units na same na. So, ito, joules to and then to kilojoules, hindi sila magkaparehas. Kailangan natin i-convert yun. So, negative 36, wait lang, convert. So, negative 36.8 joules per Kelvin times sa isang kilojoules is equals to 1,000 joules. So, imamainas lang to ang joules, and then, yung sinabi ko na, i-move lang 3 times yung negative pa left. So, magiging negative, 1, 2, 3. So, 0.0368. So, yun yung kanalabasan nito. Ito yung kanalabasan nito. So, ito yung kanalabasan nito. Magiging kg per Kelvin. So, yan na yung value niya in kilojoules. So, ito na yung value niya. So, iyan natin muna yan. Itabi. Conversion. Asanan natin. Then, we input na. So, we already have the given. Okay na yung values niya. So, input na lang natin. So, the enthalpy, negative 144 kilojoules minus the temperature, 298 Kelvin, lagyan natin, times the negative 0.0368 kilojoules per Kelvin. So, next is to do maths. So, i-times mo na to, maka-cancel out yung Kelvin. So, matitira is negative 10.9664 kg na lang. Diba? So, negative 144. So, ngayon, pwede na yan i-add. Kasi nga, same na sila units. So, bago yan, i-add na natin yung sign dito. So, magiging positive yan. Magiging positive to. So, G for kg. Positive na, ay plus na, kasi nga, yung both signs, so negative times negative is positive. So, 10.9664 kg. So, pwede na yan i-add. G is equals to negative 133 kilojoules. So, ito na yung sagot. Yan na yung sagot. Spontaneous if negative siya or less than 0. So, less than 0 siya, diba? So, this equation is spontaneous. Kasi nga, less than 0. Negative siya. So, yun lang. So, guys, yun lang ang discussion for today's video. So, we hope na naintindihan yung spontaneous change, entropy, and yung Gibbs free energy. So, yun lang. We hope na naintindihan nyo yung discussion. So, thank you for watching.